we define the sine of alpha as the ratio of the opposite leg to the hypotenuse, and the cosine of alpha as the ratio of the adjacent leg to the hypotenuse. That is in the case when alpha is an acute angle of a right triangle. But what about angles that aren't acute? Can we define the sine and the cosine for them? Yes, we can, and for that we'll use the unit circle with center at the origin of a Cartesian coordinate system. Let's first look when alpha is an acute angle. If we denote this point by M, and the foot of a perpendicular to the x-axis by N, and on the y-axis by P, then the sine of alpha is equal to Mn over OM. And the cosine of alpha is equal to ON over OM. But NM is equal to OP, and OM is equal to 1. So the sine of alpha is equal to OP. And similarly, the cosine of alpha is equal to ON over 1, which is equal to ON. The key here was that the radius of this circle was equal to 1. Now, what are the lengths of ON and OP when alpha is an acute angle? Well, they are just the x and the y coordinate of this point M. So the cosine of alpha is the x-coordinate and the sine of alpha is the y-coordinate of point M. Therefore, instead of looking at ratios of the sides of a right triangle, we can look at the point on the unit circle and we can say that the sine of an angle is the y-coordinate while the cosine is the x-coordinate. But why would we do it that way? Because now we are no longer limited to acute angles. If, for instance, alpha is an obtuse angle, then the sine of alpha is the y-coordinate of this point, while the cosine of alpha is the x-coordinate. So in this case, the sine of alpha is greater than 0, while the cosine of alpha is less than 0. We started by recalling how we defined the sine and the cosine of an acute angle of a right triangle. Then we applied those definitions on the unit circle. It turned out that the sine of alpha and the cosine of alpha are coordinates of the point M on the unit circle. We then decided to use that as our definition of the sine and the cosine of any angle. Finally, we showed an example when alpha is an obtuse angle, and in that case, the sine of alpha was positive, while the cosine of alpha was negative. With that in mind, I leave you with this question. For which angles alpha is the sine of alpha equal to 0, and for which is the cosine of alpha equal to 0? That is all for this video. If you liked it, click the like button, it helps with the YouTube algorithm. And I'll see you next time.